Hello, in this video I'll try to explain interfacing of 4x4 keypad to LPC1768 microcontroller to display a number on 7 segment display. So the 4x4 keypad essentially consists 16 switches or 16 push buttons, and these switches are arranged in the form of matrix of 4 columns and 4 rows. Your microcontroller need to identify which key among the 16 is pressed. Okay, in order to identify the key pressed, we are going to use a row scanning method. Means at any particular time, any one row among the 4 has to be activated. For example, assume that we are going to scanning row 1. That means row 1 should be logic 1 and remaining row 2, 3 and 4 should be logic 0. If row 1 is logic 1, and assume that if the switch 1 is pressed, then row 1 and column 1 is electrically get connected, thereby column 1 is also logical. Okay, so you have to activate a row and you need to read the column. Okay, suppose if the switch 2 is pressed during row scanning 1, then the column 2 will returns with logic 1 value, whereas column 1, 3, 4 returns with logic 0 value. Okay, suppose if you want to scanning row 2, if you are scanning row 2, then row 1, row 3, row 4 should be logic 0, and during this row 2 scanning, by reading the column status and identifying which column is returning with logic 1, you can identify a corresponding switch. For example, if you are scanning row 2 and if sixth switch is pressed, then column 3 returns with logic 1 value, whereas column 1, column 2 and column 4 returns with logic 0 value. Okay, so your microcontroller should identify the which key pressed, okay, by scanning the row in a sequence manner. Means at a particular time it has to scan only one row. During that row scanning, it has to read the column. If any particular column returns with logic 1 value, then a key pressed can be identified. Okay, so this is how to identify key pressed in a matrix of 4x4 keypad. Okay, so from the perspective of the microcontroller, the R1, R2, R3, R4, that is row lines, should be an input line. That means your microcontroller should send logic 1 value in a sequence manner to these row lines, and the column 1, column 2, column 3, column 4, these column lines are output line, so that your microcontroller should read all the column status during a particular row scan. Okay, so these column lines are acting as an output lines and row lines are acting as an input lines. Now looking into the schematic of the kit in the lab, so we have 4x4 switch matrix is as shown in the figure. So row 1 to row 4 are supposed to be act as an input line, and column 1 to column 4 should be act as an output line. Let us identify the pins corresponding to the row and column. So column 1, 2, 3, 4 from the connector B, in turn it's connected to pin number 1, 2, 3, 4 of the connector, that in turn identified as 15th, 16th and 17th and 18th pin of port 0. Thereby the 15th, 16th, 17th and 18th pin of port 0 should be in turn it's connected to column 1, column 2, column 3, column 4 respectively. Therefore the 15th to 18th pin of port 0 should be act as an output port. Okay, so through this port, through this pin of port 0, your microcontroller is going to read the status of the column. And similarly, the row lines of the switch matrix is in turn connected to 5, 6 and 7 and 8th pin of connector B. In turn, those pins of the connector is connected to 19th, 20, 21 and 22nd pin of port 0. Therefore, the pin number 19 to 22 of port 0 are connected to row lines of the switch matrix, and these port pins is acting as an input port pin. Means at any particular time your microcontroller should send logic 1 either to 19th pin or 20, 21st and 22nd pin in a sequential manner, and each time when it's going to activate a row, then it has to read the status of the column via pin number 15 to pin number 18. Thereby it has to conclude which key among the 16 is pressed. Okay, and the schematic for 7 segment display is not shown in this video because in the earlier video, to interface the 7 segment display to LPC 1768, we have shown and explained the schematic and the program flow. So since the same program is also used as a part of this experiment, we are not going to show the schematic again. Now let us look into the algorithm of the program flow. So you have to identify the pins with the help of schematic given, and it's already identified, and configure those pins as general purpose input output pin. Set the direction of the pins. It's very essential that all the column lines should be set as an output, whereas all the row lines should be set as inputs. And you have to scan row by activating one row at a time. That means your microcontroller should send logic 1 to a particular row line through a pin 1 at a time, and then you have to read the status of the column through the output port pins. And if the key is pressed, by finding the row value and the column value, you have to identify which key is pressed, then the corresponding number of the key must be displayed on the 7 segment display. This is about the algorithm of the program. Now let us look into the program. So these two are the header files. Essentially all the registers associated with LPC 1768 are available under the header file lpc17xx.h, and we must include standard input output .h file .h header file here. These two are the header files. Now this global constant importance is and the value is also explained in 7 segment display. This is a global constant should be declared to select any one 7 segment display among 4. There are 4 7 segment displays are available in the kit. Among that, at any particular time you have to select only one. So these are all the values, and in the earlier video we have in detail we have discussed about how these values are established in order to select any one 7 segment display among available 4. Okay, so that's why we are skipping this information here. Now in this section we'll discuss what are the variables declared here, variables and arrays which are declared here. So the first array declared here, scan underscore code. It is an array and there are 16 elements in the array. So each element is of character type. So your compiler is going to reserve 8-bit for each of the element. So these elements corresponds to the row value and the column value. The first nibble or first the higher nibble of this hexadecimal number corresponds to column value, and the lower nibble of the hexadecimal number corresponds to row value. This one indicates the column 1, and this one indicates row 1. So this is whenever key value returns with 0x11, that means the first key in the matrix is pressed. Column 1, row 1. Similarly, this is column 2, row 1. So this corresponds to the first row. Okay, the different switches in the first row. So this is column 2, first row. Column 2 means this first position of the nibble. Okay, this is 0th position of the nibble. So obviously the hexadecimal value is 1. And for the first position of the nibble, the hexadecimal value is 2. And this is the second position of the nibble, therefore the hexadecimal value is 4, and this indicates column number 3. And fourth position of the nibble, higher nibble, is hexadecimal value 8. Okay, so this 8 indicates column number 4. Okay, and 1 1 1 1, the lower nibble of each hexadecimal number indicating row 1. Correspondingly, for the second row, this one indicates column 1, row 2, column 2, row 2, column 3, row 2, and column 4, row 2. Similarly, for third row and fourth row, the hexadecimal values are established. Okay, so this is an array of 16 elements indicating the row value and column value, in turn which is trying to indicate which key among the 16 is pressed. Okay, now we are declaring another array named as array underscore decimal, which also consists 16 elements, and it is of unsigned character type. So obviously your compiler is going to reserve 8-bit for each element in the array. So here these values corresponds to the number that's supposed to be displayed for each key. For example, if the first key is pressed, your microcontroller is going to display 0 on 7 segment display, and if the second key is pressed, it is going to display 1 on the 7 segment display. Likewise, the different number that's supposed to be displayed on 7 segment display for the corresponding key is listed in this array. So this is about declaration of the two arrays. Now we are declaring some variable. So let us consider temp2. It is an unsigned long integer. So your compiler is going to reserve 32-bit space for temp2. So this temp2 variable is going to hold a value that's supposed to be display on the 7 segment display. Now we are going to declare variable row key found, key underscore found, and key. It's of character type. So row is initialized with 1. Okay, initially the value of row becomes 1 now. Now also we are declaring variables I, j, variable 1, row underscore value, column underscore value. It's of long integer type. So this row 1, actually this particular variable is used to check which row is supposed to be scanned. So obviously when initialized with 1, the first row is going to scan, and after scanning the first row, the row supposed to be incremented. It becomes 2, it becomes 3, and it becomes 4, and we have to check the loop so that the row value should be within 1 to 4 only, so that each iteration the row value will be incremented by 1 and it will be limited to a maximum value of 4. So which indicates which row among the 4 is going to scan. And key underscore found is to check whether the key is pressed or not. If the key is pressed and if the corresponding key is found, so that this is just acting as a flag, okay, to indicate whether the key is pressed or not. If the key is pressed, so this key underscore found becomes 1. Otherwise it's going to scan the other row. Okay, and the key is a variable, so which holds which key among the 16 is pressed. The value of the key may be from any value among these 16 elements. Okay, and now we are coming with another variables called ij, variable 1, row underscore value, and column underscore value. So ij for in a for loop for counting, holding a count initial value of the counter. So we are going to use the I and j, and also variable 1 to hold appropriate value that's supposed to be passed via port pins during the row scanning. That value is supposed to be holded in variable 1. Row underscore value and column underscore value is going to hold the which row number scanning and the column number of the switch is pressed. Okay, so these are all the variables corresponds to the program. Now the functions in the programs are, one is display function. So in this function we are going this is to display a particular number on the 7 segment display, depends upon the key, which key is pressed. Some delay routine and scan function. So in this scan function, so there is a process of row scanning and column reading. That process is going to happen in this scan function section. All our null function doesn't return anything to the main program. Now let us consider the main program. So initialization of the main program. So these two are the mandatory statements: system initialization and system core clock update. There are these two are CMSAS function. In order to update the clock value and PLL, these functions must be declared. Now the first point is the selected pins must be configured as a general purpose input output pin. So obviously the pins identified as P0.4 to P0.11, this is for 7 segment display, and P0.15 for column 1. These pins will belongs to port 0 and they will fall between 0 to 15th pin. Therefore we have to use pin selection 0 register to configure these pins as general purpose input output pins, and you have to the corresponding value is 0x3f 0000ff, and how to identify this value for pin selection register is discussed in the introduction video. Please, it is suggested to refer that video. Okay, and now for a column and row, for column 2, 3, 4 and row 1, 2, 3, 4, we are using a pin number 16 to 22 of port 0, and since these pins are belongs to port 0 and they fall under 16 to 31 group, you have to use pin selection 1 register to to configure these pins as general purpose input output pin, and the values you have to identify by forcing appropriate value into the particular position of the register. This value can be established. Similarly, to enable one 7-segment display among the 4, so we are using pin number 23 to 26 of port 1. Therefore, the associated register is pin selection 3 should be used in order to configure these pins as general purpose input output pin. So in this section of the program, we are configuring the required pins as a general purpose input output pins with appropriate by choosing the appropriate pin selection register and by forcing appropriate values for this pin selection register. So now the next section is to set the direction of those pins, and pin 4 to pin 11 for 7 segment and pin 19 to pin 22 of rows, that row lines should be an output line. Therefore, these corresponding positions of FIO direction register should be made as 1 and are supposed to be logical, and remaining positions of the FIO DAI register should be considered as 0, and that value established as 0x00780FF0, and this value should be logically ORed with the earlier value of the FIO DAI register. Thereby you are ensuring only these pins are directed as an output, whereas the remaining pin direction will be unaltered. Okay. Similarly, port 1 the P1.23, that means of 23rd pin to 26th pin of port 1 is also acting as an output line in order to enable one 7-segment display among the 4. Therefore, since this belongs to port 1, that's why you have to use a structure called LPC_GPIO1, and in that structure the corresponding value of FIO DAI register should be changed. That means those bit position values must be made as 1 and remaining bit position should be assumed as 0, and that is logically ANDed with the earlier value of the FIO DAI register. So these pin positions are pins also directed as output. And very important point, the 15th to 18th pin of port 0 is an input port, because the microcontroller should read the status of the column after every row scan. That's why these pins should be configured as input port. Now to configure this input port, since this belongs to port 0, under the structure LPC_GPIO0, this particular positions of the pins must be made as 0, whereas the remaining position of the bit register should be assumed as 1, and the value established is 0xFF87FFF. This value should be logically ANDed with the earlier value of the direction register. Thereby you are ensuring only these particular pins are configured as input pins, and remaining directions of the remaining pin direction will be unaltered. Okay, so this is about configuring the pins as GPIO and setting the direction of the pins. And now this is a statement. In order to select the first segment, we are reading the constant first segment to the FIO pin. So thereby you are selecting the first 7-segment display among the 4 as a display unit. Okay. Now while 1, this is an infinite loop. Continuously this loop will be executing as long as the power is supplied for the microcontroller. So initially key found is a flag. It is initially initialized with 0, indicates that no key is found. Okay, and now we are calling the scan function. So we'll go to look into the scan function. This is a scan function, so it's a void scan, so it doesn't return anything to the main program. So while 1, so we are using a switch statement. So in a switch statement there are 4 switch statements. In the first switch statement we are loading a variable 1 with a value 000800000. This corresponds that the first row of the key matrix is going to activate. Means only the first row of the key matrix, the pin associated to the first row of the key matrix will be logic 1, and remaining bit positions will be made as 0, and we are going to increment row as row plus plus. Initially the row value is 1, now it is going to increment it as 2. Okay, we are checking whether row value becomes 5, to ensure that the row value should be in the range from 1 to 5. So after every time incremented the row value, it has to be checked whether row is equals to 5. If it is 5, we have to reset it to initial value 1. Okay, now so we are now the variable 1 value, which corresponds to activate first row of the key matrix, is read to the variable row underscore value. Now this with the help of clear register, we are going to clear all the row pins. Okay, 7800 corresponds means the port pin which connected to the row lines of the key matrix will be ensured it is 0. Now we are going to set we are going to force a value variable 1 value to that particular pins with the help of FIO set register. That ensures that only row 1 is going to set and remaining row values will be 0. Okay, now key found, initially the key is not found, that's why it is declared as 0. Now column value, initially it is 0. Now we are the column value is equals to, initially it is 0. Now we are going to have a statement that the LPC underscore GPO FIO pin, the FIO pin is a register which is going to read the complete 32-bit information of port 0. So that complete 32-bit information of the port 0 is going to OR with column value. Initially all the 32 bits of the column value is 0, and that is going to OR with FIO pin register. Now this column value consists the complete 32-bit information about port 0. Now it is going to AND it with a value 0007800. This is different, this 0007800 to ensure the row values are 0. And now look at the bit position, this is 0007800. This value corresponds to the pins associated with the column lines. Okay, the pins which are connected to the column line, those bit positions are considered as 111, and it is logically ANDed with the column value. This process is to read the column value. Okay, so we are just through this statement we are reading the column value. If a key is pressed, the corresponding column should be returns with 0. So if the key is pressed, this particular statement returns a true value. If none of the key correspond to the row 1 is pressed, then this returns with false value. Okay, so now we are checking whether this is true or false. Okay, this if statement, a column underscore value is 0 or not. If the key is pressed, if statement returns with true value. If key is not pressed, this if statement returns with false value. Assume that the key is pressed. Okay, in that case, after some amount of delay, so just with a small span of delay, so the key found flag is set, so that indicates the key is found. And next stage is to identify which key it is, so that we are going to frame the higher nibble and the lower nibble from the column value and the row value. Okay, here the row value is already read by the variable 1, that means it is corresponds to the first row. Since in order to frame the higher nibble and the lower nibble, the column value, the value which is stored in the variable called column value should be right shift by 11 position, so that it frames the higher nibble of 8 bit. Similarly, the row value should be right shift to the 19th position, so that it's going to frame as lower nibble of the 8 bit number. Now by ORing column value and the row value, we can establish the key which is pressed. Okay, key is equals to column underscore value or with row underscore value, which in turn is going to establish the key which is pressed. Okay, if the key is pressed, we are going to break the switch statement. Means if key is pressed, it doesn't scan the further rows in that sequence. Okay, if key is not found, that means if the column, if key is not pressed, obviously all the bit positions of corresponds to this column will be read as 0. So the statement column underscore value and equals this value, this statement returns with false value. So obviously this if statement is also become false, and we are going to break. That means this statement is skipped. Again, variable 1 will be loaded with another value. This value corresponds to row. So this process is repeat. If key is pressed, the key which is pressed will be identified in the main program. If the key is not pressed, this process will be repeated. Okay, we'll go back to the main program. So after break, your program control will be go back to the main program. Here this is an iteration. Since there are 16 key, so in this iteration we have to find which key among the 16 is pressed by matching the key value with the element value in the array scan underscore code. So if the key value is matches to the any one element among the 16 in the scan underscore code array, then the corresponding elemental value in array underscore decimal will be displayed. Okay, that's why that corresponding elemental value in the array underscore decimal will be loaded to a variable called temp2, and that main program will be breaked here, and then we're going to call the display function. Okay, so in display function, so this is a display function where since the temp2 hold a value which starts from 0th position, but the pins connected to the 7 segment displays actually start from pin number 4. Now to match that particular pin position, this value which is holded in the temp2 should be left shift by 4 position, and it is ensuring that those 4 pins, initially those 4 pins are 0, and now we are going to set those 4 pins to display a particular value in a 7 segment display. So this is about display function.